Today I'm going to describe how to derive an equation for velocity in terms of time when dealing with drag. Now, drag is a common topic in physics because it happens in lots of scenarios, such as in free fall. We have the force of gravity acting downward and the force of drag acting upward. The force of drag here is represented by kV. V is the velocity, k is a constant. When you subtract the drag force from the force of gravity, we get ma, a being the object's acceleration. Now, to find the terminal velocity, or when acceleration is 0, we set the drag force equal to the force of gravity, which I've done here, and we find that mg over k is equal to v terminal. Now, to integrate this expression to find the velocity in terms of time, we have to change acceleration to its definition, which is the derivative of velocity. Now I'm going to divide everything by k. Now, the reason I did that is because what's left over here on the left side, mg over k, is equal to the object's terminal velocity. So I'm going to substitute v terminal in to simplify this expression. Now, we have a negative velocity here, and we want that to be positive, so I'm going to multiply everything by -1 and rearrange the variables. Now, to integrate, we need to have velocity on the same time as dv. So what I'm going to do is divide everything by v over v terminal and multiply k up, divide by m, and multiply by dt. Alright, now we can integrate. Our limits of integration are going to be from time 0 to time t, and from velocity 0 to velocity v. Now, the integration on the left side is very simple because negative k over m is a constant, so that moves outside of the integral. The integral of dt is just t. And because we're doing it from time 0 to time t, at time 0 this cancels out, and at time t it's just equal to negative k over m t. Now, the integral on this side is a little bit more difficult because v minus vt is on the bottom. So if we remember the rule du over u, the integral of that is equal to the natural log of u. And if we treat v minus vt as u, we can use this rule, and this is what we get. So remembering to use the limits of integration, we get natural log of v minus v terminal, subtract natural log of 0 minus v terminal. If we remember the rule that subtracting natural logs is the same as dividing within them, so we get this as our new expression. Now, we can rearrange what's on the inside of the natural log. And now we're going to get rid of the natural log by undoing it with e. We're going to do e to the power of each side of the equation. This will cancel out the natural log. Now, remember, we're finding an equation for velocity in terms of time, so we want to get velocity by itself. So I'm going to rearrange the variables again and multiply everything by v terminal. Now we can substitute back in for v terminal if we remember that it's equal to mg over k. And there we have a general form of the equation for velocity in terms of time when dealing with drag.